Hello, welcome. Uh, Good morning, good afternoon, good evening, wherever you are. This is the MANET working group. Um, we have a 1 hour session, so we're going to get going. The slide just gives some details about the working group and the chairs. We've got Ronald, Don in the room, and we've got Donald online. And we've also got Jim, our AD, online. Just draw your attention to the Notewell slide. Most of you will already have seen this, but we were told to give you a minute just to go over it. It talks about the policies and procedures, the IETF, and the expected behavior, et cetera. If you need any more information, there's a lot of pointers on here to information. And if you have a question about anything, please ask. And we also bring your attention to the note really well about the behavior in the group, our anti-harassment procedures, and that we maintain an environment that's good for working, friendly environment. And again, if you have any questions or issues, you can consult the documentation on this. So just some notes again, you've mostly all seen this. Please sign into the data tracker. Just a note, this is a 1 hour session, so this room, Anima will be after this. So I think the data tracker will take care of that, but anyways, just a note. If you're in the room, you can use the light client, and you should use the client to get into the queue. And please make sure your audio and your phones are off, etc. So we have a fairly short agenda. We've got the agenda bashing. We'll go over the milestones. We have a presentation on OLSR v2 tweak by Christopher Dearlove, and another presentation on IPv6 addresses for Ad-hoc Networks from Fred Templin. And then we're reserve some time for charter revisions discussions and wrap up. Do you want to take this part or?
Okay. Yeah, a brief update on where we are with some long pending drafts that we have. We have been making progress in the last few months. And this is all about the credit-based flow control DLAP extensions. Two of the drafts, which in fact just define the extension ID, are now past IETF last call, and the other two of this cluster of 4 have just entered IETF last call. So by next week or so, they probably also make it through. We haven't seen any comments yet. And then there's a bunch of directorate reviews going on for these drafts as well. But yeah, they're in the pipeline. What will follow is of course the reviews by all ADs, and we fully expect there to be some discussions and comments, but we deal with them as they come along. I am the document shepherd for these drafts anyway. Next. Then there were some drafts by Henning Rogge about physical layer-based DLAP extensions that were adopted into the working group about 5 months ago or something. We really could use some reviews and comments on these. I mean, Don has just commented on one of these. I also have some comments in the works, but it would be really good if other working group participants would be able to have a look at these and state their opinion and suggest changes. Then we have 2 related drafts beyond the 2 that are on the agenda and will be presented today. There's this draft by David Liu and co-authors that was presented, I think, last summer in San Francisco. Since then, there have been two updates. However, when we asked when we did the call for presentations for this meeting, we did not receive a reaction from those guys. AODV was presented in Brisbane by Charlie Perkins. And when we come to the charter update part of this session, we'll talk about that a little bit more.
Jim, you in the queue?
Yeah, I just wanted to clarify for the working group that the 4 documents that I have right now, 2 of them, as you mentioned, have already finished last call, and 2 are in last call. I haven't moved them forward. I'm going to move them forward as a block of 4 because they're interrelated. So I figured it was best to put them all through in one shot. Then the ISG reviewers will have some background. So that's why you're not seeing those 2 that have already gone through last call on the telechat yet. I just wanted to make that clear.
Okay, thank you.
Yeah, that's perfectly fine, and that's actually what we would. That is our preference anyway. Is there another slide on draft stats?
I think
That's it, right?
Okay, so next up on the agenda, if we have any note takers, please, contribute to the notes. We do have the closed captions, which we've been consulting heavily on for notes, etc. But please, if you can contribute to the notes, that'd be great. Okay, Christopher, you have the floor.
Okay, this is a presentation on a short internet draft, which I put together just covering a small gap in OLSRv2 used in certain ways. Next slide, please. So the motivation is one particular scenario which I'm about to present, but it isn't limited to use in that specific case. Next slide, please.
Okay.
So the motivation is the case of a near static network where nodes are arriving, nodes departing, but nothing else is happening. So fixed period messages might not be one way of doing that, might not be the best way to handle those. One approach is backing off message intervals, which is not actually specifically described in any draft, but because OLSRv2, all parameters can be changed at any time, is an option. The motivation here is the more extreme case, not having any periodic messages at all, or only some periodic messages, but that's merely the sort of motivating case. Next slide, please. As I say, supposing only networks are arriving or sending, OLSRv2 is very much got the options of only sending messages, responsive messages as we call them, because the word reactive was taken, in response to network changes. I mean, normally those would be in addition to periodic messages, maybe allowing longer periods. So responsive messages is not new, and you could implement no periodic messages at all by just setting an infinite, the very long, which is effectively infinite, it's days message interval, is if you wanted to actually implement it given an existing implementation of OLSRv2. Next slide, please. So there are two effects we're talking about: routers arriving, routers departing. We're assuming everything else is static for purposes of this example. So what happens if a new router turns up? We'll get an exchange of hello messages in its neighborhood, assuming everything's responsive and all neighbors will be updated and all 2-hop neighbors will be updated. Everything will work locally. If a router leaves, maybe that router can send a hello message with no information in it, with no neighbors to say it's going. If it doesn't need that, and we can't rely on the data link layer because all we need is a binary, I'm not here. So maybe the data link or the absence of it could do that for you. Or failing that, you would actually still need to stick to having hello messages in order for locally OLSRv2 to work in this scenario. Next slide, please. So we might still need periodic hello messages, but TC messages are worth I'm getting slight crosstalk there from someone. Josh Cohen, could you? Yes, thanks. So TC messages, and do we still need those in this static scenario? And it's worth noting that TC messages are the main barrier to the scalability of the network to very large scalable protocols, very large networks. Hello messages go up linearly with a number go up. They're constant locally at any one node, but TC messages, the bigger your network is, the more TC messages any one node has to send. So we'd like to not have to send them. So we could stop sending them in this scenario. But what happens? So routers will accumulate information about departed routers because nobody's told them they're going, because they're not sending that information out. But, and there's an argument in the draft to say why this is the case. I'm just going to say it here. That information doesn't do any harm because it's never used. And the new router will send out TC messages responsively as it's learned its neighbors, as it sets up its MPRs and all the rest of that stuff. So remote routers will get to find out about new routers that are turning up. But that doesn't work in reverse. And that's the key point, the reason for this draft. If a new router pops up, although remote routers may get to find out about the new router won't find out about anything in the network beyond its local neighborhood, at least using the messages that are advised in OLSRv2. Permitted, you can send anything at any time. So we're talking about non-backwardly compatible changes. Next slide, please. So one solution to the problem of not knowing what's going on globally is some form of local database exchange, which has been proposed in the literature, and there's a reference in the draft. But that's not a backwardly compatible change, or at least in the sense we're talking about here. And so that's not part of this draft. The solution within the scope of using existing messages, not creating new messages, which a local database exchange would be, is that a remote router could send a TC message when it learns that a new router's popped up. And how would it learn a new router's popped up? That would be because it adds an advertising remote router tuple to its set. So therefore, the proposal is that a remote router has the option of sending a a TC message when that scenario turns up. And you'll notice I say may, should, shall. In the draft, there's a suggestion for when it's may, when it should, and when it shall. May, because it already may, because there's already permission for routers to send messages whenever they want to, but there's no suggestion that they should do so. Should, if you're heavily relying on responsive messages in your network, that's the way you've designed it, then you should send messages in that case. And if you're fully following the approach of no periodic message at all, then in order for the network to work, we're into a shall. And that is, so the core of the proposal is just the normative part of the proposal is basically that last paragraph, well, those last two paragraphs. Everything else that I've presented is motivation rather than normative text. And so on to the next slide, which says I've basically presented where this is coming from and what it says. As it says, there's a couple more slides that I decided to leave out for reasons of time. But we'll see if people have any questions.
Yes, we have Julius in the queue.
Hi. I think so. The idea of having reactive features in a proactive protocol is a very old idea. The oldest normalized case of that I know are the reactive extensions to RIP. Remember RIP? This probably the first. Yeah.
Before my time,
anyway,
but yes, I know of it.
Okay, and that was deprecated because it didn't work very well. And I know that a lot of people have tried doing things like that, and the results have been that if you manage to get it work, it doesn't work very well. The problem is that if you're trying to be reactive in a proactive protocol, there is some point at which you are going to do a path discovery, and the path, in your case, it's going to be TC exchange, and you end up in actual networks finding out that the amount of traffic is larger than the amount of traffic you would have by being purely proactive. Now, I'm not saying that you're not going to succeed. What I'm saying is that if you do succeed, I'm going to learn a lot, that this is not a trivial thing. So I encourage you to try it out. And I definitely encourage you to try it out. But I think that as long as we don't have any evidence that it actually can be made to work, I'm not sure that a normalization group is the right place to do those things of experiments unless we have good evidence that it actually can be made to work.
I think that's a fair comment. Unfortunately, my position in being able to carry out those experiments is essentially not there because I am now a retired person, no longer working for BA Systems, so I used to work.
Then you're in a great position to do the experiments.
Oh, believe me, what I want, and I'm making tentative inquiries, but it's not really working. To say what I'd like is access to the software I wrote for my former employer that has.
Sure, I understand. But the point is that if you manage to make it work, I'm going to steal your ideas for Babel straight away and take it as a compliment.
Right. Okay. Thanks for your comments.
Okay, is that it?
The only thing, sorry. The only thing I would say is that I think the working group has a sort of the options of saying, yes, we'll adopt this and we'll consider it, or we'll say, no thanks, we don't need this. It's up to the working group and discussions here and on the list as to whether it wants to take this any further or not.
Yeah, we'd like to take it to the list then and get comments, and then we can consider the next action based on the comments.
Yes, I think It would be fully covered by the current charter to pick this up. So that should not be a reason not to do it, because I would see this as OLSR v2 maintenance and extensions, and that's covered. But
Yes,
let's get some comments.
It's another case like, is it 7466 or 7446? I forget which. Too many numbers.
We'll take one more comment.
Stu?
Stu here. Just responding to the previous comment about trying to put some reactive behaviors in a primarily proactive routing protocol and how that is likely to pan out. In my admittedly somewhat limited experience, that's going to be sensitively dependent upon the rate of topological change. I've dealt with networks where the where the joins and the splits are quite infrequent, and so there's maybe a little bit of flurry of traffic at that point, but that's it, and it doesn't create a big burden on those networks.
I think that the motivating scenario doesn't include joins and splits, but the option, and maybe it's a question of presentation, the option would be something that might accelerate the formation of a less static and one that's still using periodic messages, but longer ones. Anyway, yeah. Okay.
Okay, could we get the next speaker? Fred?
Hi, I'm Fred Templin from Boeing, and this is about IPv6 addresses for ad hoc networks. So before we get started, let me just first ask you to all imagine that we were all instantly teleported to the Northwest Territories with nothing but the clothes that we're wearing on us and our cell phones. There's no cell towers within hundreds of miles, but we should be able to form a little ad hoc network among ourselves just from our cell phones going device to device. So go to the next chart, please. So what that would look like in terms of a topology is something like this, where we have a partial mesh where nodes have neighbors. Node N2 in this example, for example, has neighbors with nodes N4, N3, and N1. But N1 only has neighbors with nodes N2 and N5. So we should be able to do multi-hop communications to keep all nodes within this mesh, or all of us there in the Northwest Territories able to be in communication with each other. But the question is, what kind of addresses do we put on our radio interfaces when we're acting in this ad hoc mode with our cell phones? RFC 5889 recommends globally unique addresses and unique local addresses. But the problem with that is that isolated ad hoc network coordinated provision is often not possible. So when we go to the Northwest Territories, we don't have a DHCPV6 server with us, and we don't have a router sending router advertisements with prefix information options that we can do stateless address auto configuration from. RFC 5889 also explains why link local addresses are limited use. It's because the ad hoc network interface is multi-link in nature. So look at that node N2, for example. We have a single interface, but 3 point-to-point links underneath it. It's a multi-link, it's not just a single link. So what we really need is a new type of addresses called multi-link local addresses. They have to be extremely high assurance of ad hoc network uniqueness. They need to be self-generated by the node or coordinated with the registration authority. And the uniqueness properties need to persist across network partitions and merges. Must be able to support localized multi-hop forwarding over multiple links. And we assign them to the ad hoc network interfaces as /128s. No prefix, just all identification. Next chart, please. So these MLAs are 128-bit identifiers with well-formed IPv6 prefixes, and that also makes them valid IPv6 addresses. The nodes assign the MLAs to interfaces as /128 optimistic addresses according to RFC 4429. And you see in the figure to the right there, we've now assigned addresses to these interfaces that are all /128s. The nodes inject the MLAs into the ad hoc network routing protocols as host routes. Example routing protocols are the ones that come from this group. It supports ad hoc network local IPv6 multi-hop routing and forwarding. And it also applies equally for static networks that are not particularly mobile or wireless. That's why this has been targeted for 6-man instead of MANETs, because it's for all ad hoc network types, not just MANETs. Next chart. So I've already covered this. I won't go into this chart again. So let's go to the next one. So there's 3 different types of MLAs that we're looking at right now. The first one, called type 1, starts with the prefix 2001 TBD :/28. And we want this to be an IPv6 prefix of 28 bits followed by 100 random bits. The 100 bits of randomness makes so that collisions are extremely unlikely. So IPv6 nodes can self-generate these addresses and assert them with an ad hoc local scope. And these addresses should not appear in a global name service. And there's an example of what one might look like. Next chart. The next type 2, is called ORCID v2, which is Overlay Routing Cryptographic Host Identifier. And it's also known in RFC 7401 as the host identity tag. It begins with the prefix 2001:20:/28, followed by an ORCID-generated algorithm ID, and followed by a 96-bit encode hash of a context ID. IPv6 nodes can again self-generate and assert these addresses without supporting infrastructure, but with fewer random bits, 96 bits that are pseudo-random. And it can serve as a node identifier, but it also can appear in the global name service. And here's an example of what one looks like. Next chart. Now, the type 3 MLA is known as the Hierarchical Host Identity Tag, or DRIP Entity Tag, in RFC 9374. This begins with the prefix 2001:30:/28, followed by a 28-bit hierarchy ID, followed by a HHIT suite ID, and followed by a 64-bit ORCID hash. These kinds of addresses need to be registered with the registration authority before we use them. Ad hoc nodes can assert register type 3s as unique addresses within an ad hoc network, and these can serve as the node identifier, and again, may also appear in the global name service. And some advantages of this type of MLA is it supports attestations of a node's claimed address, supports registration address-based authentication. And again, here's another example of one. Next chart. So what about the old site local prefix, FEC 0::/10? RFC 3879 formally deprecated site local prefixes. Implementation stopped supporting these addresses taken from that block. So even today, 20 years after the deprecation, implementation still remembered that, and some of them just refused to use that address at all. So the multi-link local addressing scope now replaces the deprecated site local addressing scope. Next chart. Assigning MLAs to ad hoc network interfaces as 128-bit identifiers using optimistic DAD. And the nodes inject the MLAs into the ad hoc network routing protocols as host routes. And this supports ad hoc network local IPv6 multi-hop routing and forwarding. Next chart. So what about ad hoc networks that connect to the internet? So what if that group of us that went to the Northwest Territories, someone had a Starlink link available with them? You can see that green node down in the lower right has a connection to the global internet. So that node can serve as a proxy server to provide intermittent or continuous internet connectivity for the ad hoc network. That node would delegate global unique addresses or unique local addresses by Slack or DHCPv6. But the ad hoc network nodes would assign those addresses to an overlay multi-link network interface, an Omni interface, instead of to the ad hoc interface itself. And you can see in this example here, we have the 2001 DB8 address assigned by node 3 to its Omni interface, not to the ad hoc interface. And once we have that kind of an assignment, the ad hoc network traversal to access the internet services via Omni encapsulation, and we use IPv6 address selection rules to choose which address to use for global communications as opposed to MANET local communications. Next chart. So the next steps for this draft, again, it's targeted for 6-man since it applies for all ad hoc network types and not just MANETs. We're looking for supporting comments on the 6-man list, but also supporting comments on the MANET list itself would be helpful too. And then we have 2 other drafts that are related to this, but the main focus we want to have taken away from this draft is this need for MANET local addresses, multi-link local addresses, and the 3 candidate types that we have. So that's what I have for charts.
Thank you. Any questions? We have Stuart in the queue.
So thanks, Fred. Obviously, what we've done over in the DRIP working group with the hierarchical host identity tag was primarily intended for a different use case, but we always anticipated that it might find other uses. And glad to work with you and support this other use case. Just want to make sure that each identifier type gets used for the appropriate cases. So the hierarchical hit is quite different from the hit. The hit, you just generate it yourself and nobody else has anything to say about it. Whereas the hierarchical hit was intended for a case where there is a registration process, and your hierarchical hit, you can only prove its validity if you have an endorsement from the hierarchy that said you really are in that branch of the tree. A long time ago, I was involved in a BOF remotely that persisted for several months as an email group, and they were looking for a router ID, and I believe it may have been in the MANEMO BOF, but it may have even predated that. Anyway, the idea was they wanted an identifier for a router that was distinct from the IP address, the locator that was associated with each of its interfaces, because how do you pick which interface is the one that you're going to use to identify the router itself, as opposed to identifying that particular interface? And we felt at that time, and like I say, it was a million years ago, that something that has the properties of a host identity tag was appropriate, because it does not imply any kind of topological aggregation. And so that's, I think, the key issue to keep an eye on. Where does topological aggregation matter, and where doesn't it? And when are you looking for a locator, and when are you looking for an identifier?
Yeah. In this case, though, we have the ad hoc network off in the wilderness with no cell towers. We're strictly identifier based at that point, /128s. And that address can serve as both a router ID and an interface identifier at the same time.
Okay, Julius?
I'm ashamed to say I haven't read the draft, but could you perhaps say a few words about why those things are not ULAs? I'm looking at the properties on slide 3 or 4, and they appear to me to be just ULAs.
So the thing about ULAs is they have a subnet ID field, and that subnet ID field is to provide a common subnet for nodes that assign addresses from the ULA prefix.
So if I may interrupt, if that's okay, you don't need, if you're doing a pure mesh network, you don't need you can just consider that all 121 bits are the node identifier, consider the ULA space as a /7, and then you just draw 121 random bits, and the MANET protocols are quite able to deal without any explicit prefixes.
Right, but
so
then
it's not obvious to me at all why the MLA space is useful here. Not that I'm opposed, I'm just trying to understand.
Right. The problem with using ULAs in that way is it conflicts with the use of ULAs that would be more structured, as there being a /64 prefix with the ULAs. And by self-assigning these MLAs that don't use the ULA prefix, but use a /128 with a well-formed IPv6 prefix, we don't get into the problem of conflictions with structured use, coordinated use out of the ULAs that we might get in other networks.
So are you worried about collisions, or are you worried about debugging issues?
I'm worried about nodes that would think that they're in a ULA subnet when they're not.
Mm-hmm. Okay. Okay, thank you.
Thanks.
If I might add, I think the issue here is you might be using ULAs in the overlay network, and if you're using those possibly conflicting ULAs in the radio network, how does the device know what's what?
That's a very good point, and that's kind of the use case I had in mind for the ULAs would be on the overlay. But what really matters with an address is what interface you assign the address to. If you assign it to the radio interface, or if you assign it to the overlay interface, that gives the context for where the address is to be interpreted.
Okay. Thank you, Fred.
Okay,
if there's any other comments, please take them to the list. And you look at the 6-man list too. All right, the next is the charter discussion. I'll hand it over to Ronald.
Yes, thank you. So I put together a proposed charter text, or I should say first Donald put together a proposed charter text. He posted this to the mailing list in the beginning of June. Unfortunately, there were no reactions. There also was no reaction from me because I was otherwise engaged at the time. But we discussed, and I now did my homework and proposed the text. I put every paragraph, so to speak, on a different slide, and I will walk you through them. The first few should be non-contentious, I would think, but you never know. And then we get to some things that might be contentious or at least deserve some discussion. And I hope that we can start having this discussion in this session. And obviously it will have to be continued on the mailing list. So here we go. Next slide, please. So this is a bit of introductory test that I remodeled a bit because I think there were lines in there that were created at the start of this working group, and I think we silently passed over our 25th anniversary last year. So this is just what we're doing, standardization for MANET, but also maintenance and extension of existing work that we have already done. And this includes the routing protocol that was developed in this group, OLSR v2, as well as Babel, because the intention is that as soon as we have the new charter in place, Babel will be closed down, and Babel activities will be continued in the MANET working group under the new charter. Next slide, please. By the way, at any point that you feel that there's something you want to react to, raise your hand and enter the queue. This is a bit of old text that I kept, mainly to highlight the point that it doesn't have to be all wireless links, especially Babel is defined to support both wired and wireless infrastructure. But I think that OLSR v2 can handle this too. Next slide, please. This is the text that was in the old charter on DLAP, the Dynamic Link Exchange Protocol, a local protocol between your router and the radios that for some reason got named modems. I'm sure that Christopher will remember the discussion. And the idea is that the routers can make better routing decisions if they have link characteristic information from these radios or modems. At the beginning of the last charter, DLAP was still work in progress, but since then it has been done, and several extensions to DLAP have been defined. So now we're more or less in maintenance mode for DLAP. We have a few more extensions pending. There might be some more coming in the future. However, I cannot think of another 100 DLAP extensions. It should be far less. So that will peter out at some point, I think. Next slide, please. Now, here is where we hopefully can have some discussion. At the last meeting, Charlie Perkins presented AODV V2 again. This has been work that was originally done in this group. At some point it was abandoned around 2016. One of the reasons it was abandoned was because it was holding up the rechartering back then. Then it progressed live as a AD sponsored draft for a number of years. And now the question is, do we need to bring it back? Is there energy in the group to work on this? Do we want this? Do we want the reactive protocol at all? Or do we just leave it be? Christopher. Christopher, you were in the queue. We lost you. Rick, go ahead then.
So I think AODVX is a fascinating concept. I would love to see it make progress. I think the working group needs to ask questions about whether it needs a document editor, because Charlie is making very slow progress with it. And I mean, he's quite retired now, so you know, some fresh blood to help make progress on it would be important, because the danger is it may go onto the charter, and then 3 years' time we'll be having a recharter conversation and we haven't made progress. So although I would like to see it done, I think it needs impetus from the working group as a whole to make it happen, or it shouldn't be on the charter.
I tend to agree. There's no point on putting something on the charter that nobody wants to work on. Christopher, are you there now?
Yes, I'm here. Sorry, I failed to click the right buttons.
Okay.
I was just going to say, in the draft charter, the main advantage of reactor solutions is low protocol overhead. I would say potentially low protocol overhead. It does depend entirely on the scenario, whether or not it is. With regard to the last comment, yes, I haven't looked at the latest, for Charlie's latest AODV draft, but certainly when it sort of fell off working group status, there were still 2 or 3 significant unanswered questions which would need to be addressed before you could. I think you would need to address them before you really adopted it as a working group item, because otherwise we'd be back round in the same circles again.
Yes. Julius?
So I'm not going to speak about whether we should adopt it. I just would like to object to one sentence in the proposed charter. You say the main advantage of reactive solution is low protocol overhead. Okay, so that's, well, there's a discussion on that. There's a lot of literature on the subject and the results are inconclusive. And I don't think that the charter should be making a stand in this discussion. So I would suggest simply removing this sentence. It does not belong in the charter. And if you disagree, I suppose we could do something like the claimed advantage of reactive solutions.
Fair enough. I will remove it. Stu?
So I'm pretty deeply divided here. I have a strong interest in hybrid routing protocols. I don't know if anybody here remembers Zygmunt Haas's zone routing protocols, ZRP, things like that. And Rick and I have had some discussions about casting all of this in a more formal probabilistic framework. And there's if you're going to have a hybrid protocol, you need to have first a reactive and a proactive protocol. So I'm in favor of keeping reactive in play here within the working group. Flip side, confession, I'm completely consumed with the drip work and do not know when I would be able to dedicate any energy to such an endeavor.
Okay, so you're not making a recommendation either way. Okay.
Still have two.
Christopher, your turn again.
I think that the basic REC/REP mechanism of AODV is well understood, and actually you don't need a fully defined AODV before you could create a hybrid protocol as an extension of OLSR v2. It's an area that in my previous employment, and so there's limited what I can say about it, that we played around with on paper, but not necessarily any further. There are one or two problems we encountered and never cracked in trying to get to the best of both. But I think that the key question, as indicated, is effort, because without effort, you're going nowhere. But really, yeah.
Thank you. Abdul Salam.
Yes. Well, I just want to say that I'm interested in this work, and I'm willing to give effort with the authors. Thank you.
Good to hear. Thank you. Next slide, I guess. This is about multicast. We also discussed this several times in previous meetings. I think, well, this is my opinion anyway, but at least Rick has made statements to the same effect that if you have a homogeneous layer 2 or layer 1 technology, you can do things to support multicast below the IP layer. And then there's no real point in trying to do another layer of multicast routing at the IP layer. However, this changes if you're using several of these layer 2, layer 1 technologies in combination, or if you're federating different MANETs with different proprietary technologies, and then you need some kind of overlay, if you will, overlay routing protocol to make this work. So I'm not sure that we are going to define a standard stack protocol here, but I think we should pursue this a little bit further and maybe do a requirements document or something. Julius?
So first, I strongly support this. And if I had infinite free time, I would start working on it straight away. Okay. Unfortunately, I cannot estimate when I will have infinite free time. And to speak about the actual text, I think that the first sentence is too weak. Okay, you're saying that the problem is the amount of churn, but even in a static network, PIM is not going to work because it uses RPF, and RPF doesn't work in mesh. And so I'll send you on the list suggested rewording. I think that here we can be much stronger.
Yes, text contributions are most welcome. Thank you. Okay, this is just a blob about coordination with other working groups, which is almost verbatim copied from the current charter, so that's not so important. Oh, Stu?
So in my work, multicast over heterogeneous media is critically necessary. And if there were at least 3 of me, then at least one of us would be working on this. There's not.
Rick?
So two quick points. The first point, echoing the previous comments about I'd love to work on this, but I think it's important for those of us who are long-term participants in MANET, we actually need to go out and find some more resources to help burn these cycles, because we understand that these topics are important. My second point actually was on the multicast piece. Ronald, I think you touched on something quite elegant there with the heterogeneous multicast, where the homogeneous islands of link layer technology are capable of handling multicast natively. There may be a middle way through this, rather than trying to build another multicast overlay network protocol, but actually more of a sort of gatewaying protocol between islands of multicast capable MANETs in a sort of bearish way. That might be more achievable than starting with sparse mode or dense mode and trying to build something new, which seems like a lot of work and quite researchy.
Yes, I can see that avoiding looping could be an issue, but let's not have that discussion now. Next slide, please. And this is the last slide. Here I enumerated a number of potential work items without claiming completeness. So if you have other ideas here, let us know. Julius.
I'm not sure how you define extensions, but if you're going to put it explicitly in the charter, I would feel more comfortable if whenever you say extensions, you would add and maintenance, just in case somebody tells us that's not an extension.
Sorry, can you say again? I missed what you said.
So every time you say X extensions, I would suggest changing it to X extensions and maintenance.
And maintenance, yeah, fair enough.
Okay, in case somebody decides to say you cannot work on that because it's not stricto sensu an extension.
Sure. Abdussalam?
Yes, regarding multicast solutions for MANET, it says here, the point says that it's based on heterogeneous wireless technology. But what about, let's say, if it's not based on heterogeneous wireless? Let's say we need at least a solution or a standard we agree on, even if it's not heterogeneous. At least we have for MANET a multicast protocol, or as before, we're already standard a simple multicast solution. But for let's say either if it's proactive or reactive, at least we have a multicast protocol for MANET. But here, if we just say based on heterogeneous, maybe it's not. I think it's maybe it's not a good start. We just say we need now a solution for multicast, and we start with it. And also regarding the other items, or even how to cooperate with other working groups, I see that it's better that, let's say, usually MANET is an old working group, but the other groups were started from maybe cooperating with this group. So it's usually case by case, or let's say I see some working group, they start with a case study or with a topology, and they start working on protocols which is related to our protocols. So we can work similarly, case by case. Let's say, if you say, let's say, as you said here, let's say multicast solution based on heterogeneous, we can say a protocol, such protocol, which is based on such case or such application. And then we can have that kind of protocol, or the authors or who are effort on that case, they can cooperate with the other working groups. But if we just say generally, now let's say we have OLSR version 2, okay, it's generally working on many, can be worked on many cases, but why don't we have some kind of group checking it, how it works on, let's say, the satellites case study? And we have already a group in IETF working on a satellite protocols. And also we have other case studies, let's say, like the ROLL, you know, or the low power. So that's another special case for.
Sorry to interrupt you, but we're almost out of time.
Okay, thank you.
So I hear what you're saying. Can you take this to the list, maybe, so that we remember all the points that you made? Yeah, I won't have time to answer all of these things now, but let's if you can send an email, then we will at least have all your points on the mailing list. So we have less than 3 minutes left. Is there anything you want to say to wrap up?
Well, maybe just if Jim has anything to say, we got a couple minutes, and then we have to switch rooms. And reminder that Anima is in here right after us, so we're gonna clear out pretty quickly.
Don, no, I don't really have anything more to add other than what I've already stated, which is in order to recharter, there needs to be, obviously technical work to do, but then you need the bodies to actually do the work. And what I've heard in the session so far is that there are some people that are willing, but pretty much everybody is unable. So that's a little discouraging, but again, let's just work on the charter to get it to where you think, but then we need to make a decision as to whether the recharter is worthwhile if there's literally nobody to work on those items. On the Charlie's work, I mean, I'm not going to recharter a working group to work on a document that only one person is actually working on. That there are other avenues for that. That Charlie needs to continue to work. Obviously, if there are other people in the working group that are actually going to commit to the work, then that's a different conversation.
Right. Okay. Well, I think that pretty well is it. We've got Anima people coming in the room, and we're going to be clearing out. So thank you very much. If there's anything else, please take it to the list. Have a good day.
Thank you.
Bye-bye.